Thank you for joining this lesson. We're going to discuss area approximation and also exact area by integration, number 18. The question is telling us that the sketch below shows a curve y equals to 2x squared plus 4x plus 3 and a straight line y equals to 2x plus 7 intersecting the curve at points A and B. So we can see the diagram. We have the curve here, whose equation is here, and we also have a straight line here, whose equation is given here. Then we have the points A and point B, where the curve and the straight line are intersecting one another. When we look at the question, part A is telling us to estimate the area of the shaded region using the trapezoidal rule with 4 ordinates. The trapezoidal rule with 4 ordinates. So with 4 ordinates means that according to the sketch, from -2 to +1, we just use intervals of 1 unit. We go up to, this will be 1 to negative, then this is 0 and 1. So with this now, we can get the values of y at the corresponding values of x, which are going to be now our heights for the trapeziums. So we need to draw a simple table here for values of x and values of y, so that I substitute in the function to get the values of y. So we are starting with the x, whereby we'll start from -2, -1, 0 and 1. So when we substitute in the function, then the values of y are going to be, we substitute -2 in this function, and we are going to get the value of y as +3. So y equals to 3. We substitute -1 and we get 1. We substitute 0 and we get 3. We substitute +1 in the function and we get +9. So those are the values of y at the corresponding values of x. Then again, there is something we're supposed to understand. When you look at this diagram, you realize that A, B, then if we call this one C, then this point D, then A, B, C, D becomes a trapezium. So area of the trapezium minus area bounded by the curve, the x-axis, and the lines x equals to 2 negative and x equals to 2, okay, to 1 positive, then will give us the area of the shaded part. When you look at the shaded part, it will be, when we subtract area of the trapezium. So let me start by getting area of the trapezium first. The trapezium A, B, C, D. So we need half multiplied by the sum of the 2 parallel lines of this trapezium, which are going to be at -2, the height here up to A is going to be 3 units. Then at +1, the height to point B is going to be +9. Then we multiply by the height between the 2 parallel sides from -2 all the way to 1. That is going to give us 3 units. So this is half multiplied by 12 times 3, and this is going to be 18 square units. 18 square units. That's the area of the trapezium. Now we are going to subtract area by the trapezium rule bounded by the curve, line x equals to 1, x equals to -2, and the x-axis. So we start by stating the formula, which is equals to half multiplied by the height, then into brackets the first y plus the last y, that is y naught plus the yn. Then we add 2 multiplied by all the other y's now in between those until the y just before the last one. So that is the formula according to trapezium rule. We're now going to substitute and have half multiplied by the interval between the values of y from this value to the next is just going to be 1 unit. From -2 to -1 to 0 and to 1, the intervals are 1 unit. Then the first y is 3, the last y is 9. Then we add 2 multiplied by the other values of y now, which are going to be 1 plus 3. Then now we compute this area. So we need a half, that is 0.5. Then we are having a 12 plus, this is 4 by 2, which is 8. So when we multiply a half by 20, we're going to get 10 square units. Now with 10 square units and the area of the bigger trapezium is 18 square units, then area of the shaded region is going to be 18 minus 10, giving us exactly 8 square units. 8 square units. Let us look at area by the mid-ordinate rule. So with the mid-ordinate rule now, we need to get again the heights. Remember, we are having 3 ordinates. So we need to get now the trapezia which had been divided. We identify the heights at the middle. So in the first trapezia, the height at the middle here. For the second one, also the height at the middle. And for the third one, the height at the middle. And that means the values of y at, we're now going to get other values of y here and x. So we come up with x and y. So we need the values of y at x equals to -1.5. That is at the mid of the first trapezia. 1.5. The next to be at 0.5, which is negative. Then finally, between 0 and 1, that is a 0.5 positive. So when we substitute in the function, the first value -1.5 in this curve, we're going to get 1.5. The next one is also going to be 1.5. And when we substitute 0.5, we shall get 5.5. So now with those values, we can get area by the mid-ordinate, which is given by the interval between the ordinates. Then we add all the values of the ordinates, all of them. So the first one, we substitute the interval, which is which is 1, from -1.5 to 0.5 is just 1 unit. So we use 1. Then the first value of y, 1.5, 1.5, 5.5. And this is exactly going to be, 8.5, This is going to be 8.5 square units. That is the area bounded by the curve, the x-axis, and the lines x equals to 2 negative up to x equals to 1 positive. So with that area now below the curve, we can subtract it from the area of the larger trapezium, which was confirmed to be 18. When we subtract 18.5 from 18, we get exactly 9.5 square units. 9.5 square units. And finally, we are talking of. By integration, calculate the exact area of the shaded region. Though area between the line AB and the x-axis bounded by the lines x equals to -2 and x equals to 1 can be found by the area of a trapezium. The way we did here, using that area equals to half a plus b multiplied by the height, area of a trapezium. We can also get the same area by integration, whereby we shall integrate the line within -2 and +1. Then we subtract area again by integration, bounded by the curve, whose equation is here, with the limits -2 and 1. So we're going to start now by saying that the area will be given by, when we integrate from -2 to +1, the line, that is 2x plus 7 with respect to x, of course, with respect to x, sorry. Then we add again integration within the same limits for the curve to x squared plus 4x, then plus 3 with respect to x. We shall get the area of the shaded part. So now we can carry out this working, whereby we need to integrate the first term, 2x plus x. This one becomes power 2, and the 2 divides now the whole term, whereby x becomes squared because the 2 will simplify, plus 7, we introduce x, but now we can ignore the arbitrary constant of integration because we are having a definite integral. Then we add in the second function 2x power 3. This now becomes power 3. Then the 3 divides everything. This will be 2/3 x power 3 plus 4x. This now becomes squared and we divide by 2. The 2 divides, so we'll have 2x squared, then plus 3x. We introduce x at that point. We don't have to introduce the arbitrary constant because again it is a definite integral between -2 and 1. So now we can substitute a -2, whereby we need -2 squared. We add 7 into -2. Then we subtract the same function. We start with the upper limit. So we should start with +1. +1 squared and +1 at this point. Then we add the same function but now with -2. So -2 squared plus 7 into -2. Yeah, that is it. Let me finish up with the first term. This is going to give us exactly 8. Then we subtract. This is going to give us a 4 plus -14, which will be -10 now. And this will be 8 plus -10 or minus -10, which is plus now. So we get 18 square units, just as we add initially. Remember, we have already calculated the area of that trapezium. Then now in the second function here, we will be subtracting. Remember, the limits are again, for this function now, the limits are again -2 and 1. So we start with substituting 1. So in the first, we're going to have -2, 2/3 into 1 power 3 plus 2 into 1 power 2 plus 3 into 1. And we subtract. We now substitute -2. So 2/3 with a -2 power 3. I add 2, -3 negative 2, then I add 3, negative 2. Yeah, like that. The second negative 2 here should be squared. So with that, now we can substitute in the calculator, and we shall have minus this one into the calculator becomes 5 and 2/3, then minus negative 3 and 1/3. So when we combine this, it becomes an addition, and we shall have exactly 9 units. 9 units. So with 18 units minus 9 square units, we shall get area as 9.0 square units. So the area by integration is 9.0, the area by the mid-ordinate 9.5, and the area by the trapezium rule is 8.0 square units.